So, good morning all, welcome to SAKALAVIDYA YouTube channel. So, now, in the last session we have discussed the matrices and determinants. Okay. So, today we are going to start the new chapter, that is Maxima and Minima. Okay. The evening session, so that I will make a plan. So, only just few joining now still. Okay. Okay. Right. So, let us start introduction. Okay. First point, let F maps A to R be a function then first point, F is said to be monotonically increasing on A. See, if x1 comma x2 belongs to A, x1 is for example less than x2, then f of x1 less than or equal to f of x2. So, now f maps A to R is a function, then f is said to be monotonically increasing on the domain A. If for example, if you consider any two elements in A, x1 comma x2 belongs to A, x1 is less than x2, then f of x1 is less than or equal to f of x2. Then we say that the f function is monotonically increasing function, or we can say that it is increasing function. Second point, f is said to be strictly increasing on A. If x1 comma x2 belongs to A, x1 less than x2, then f of x1 less than f of x2. This is called strictly increasing. less than or equal to means monotonically increasing. So, now third point, f is said to be monotonically decreasing on A if x1 comma x2 belongs to A, x1 less than x2, then f of x1 greater than or equal to f of x2. So, now we shall discuss strictly decreasing. So, strictly decreasing means actually here same conditions here, f of x1 greater than f of x2 provided x1 less than x2, x1 comma x2 belongs to A. That means f is said to be strictly decreasing on A if x1 comma x2 belongs to A, x1 less than x2, then f of x1 greater than f of x2. So, this actually monotonically increasing and next monotonically decreasing, strictly increasing, strictly decreasing. Okay. So, now next point, f is said to be monotonic. F is said to be monotonic on A if f is both monotonically increasing or monotonically decreasing on A. So, these are the important points for actually increasing and decreasing functions. Okay. So, now let us discuss second concept. That is, let f be a function on neighborhood A of small a. That means either it may be A plus or A minus. Neighborhood of A, sorry, 1 minute. Neighborhood of A real number A, then f is said to be that means locally, this now locally increasing, locally decreasing. Locally, first point, increasing f is said to be increasing at a particular point, that means at a, at a, at a, then actually here x belongs to a, x less than a, suppose, then f of x is less than f of a, then we say that f is increasing at x is equal to a. For example, suppose x less than a, f of x is less than f of a, then it will be increasing at a. Next point, decreasing, decreasing at a, x belongs to a, x belongs to a, x less than a, then f of x greater than f of a, greater than f of a. So, next, this is very important point. Generally, the most of the problems will be, we have discussed the concepts. Now, this will be third is very important. Let f be a function, f be a function defined on neighborhood a of a real number, of a real number a. In that first point, suppose if f dash a is greater than 0, derivative at a is greater than 0, then f is increasing, f is increasing at x is equal to a, or at a, say a, at a. Second point, that means if f dash a less than 0, then f is decreasing at a. That means for increasing f dash a is greater than 0, for decreasing f dash a is less than 0. Okay. Now, the problems. So, let us discuss the problems on these concepts, whatever concepts we have discussed. So, because actually I will not discuss all the concepts at a time, the concepts followed by the problems. So, first today I have discussed the concepts actually here, increasing and decreasing function, then these are followed by the problems now. Okay. First problem, the function f of x equals to 3 plus 12x minus 9x square plus 2x cube is increasing in first option 2 by 3 comma infinity, second option 1 to 5, third option is 2 by 3 comma 4, fourth option minus infinity comma 1 union 2 to infinity. This is the question. So, that means in which interval this function is increasing, that we need to find out now. Okay. So, that means for increasing function here f dash x is greater than 0. So, first step is we need to find out f dash x and f dash x greater than 0, then we need to solve for x, then we get the interval in which the function is increasing. So, let us solve it now. Solution: here function is f of x equals to, we have 3 plus 12x minus 9x square plus 2x cube. Let us find out f dash x. 0, 12x differentiation 12 minus x square differentiation 2x into 9 minus 18x, x cube differentiation 3x square into 2, that will be 6x square. We have 6 common, this is x square minus 3x plus 2. See, you remember for increasing f dash x is greater than 0. So, that means actually here 6 multiplied by x square minus 3x plus 2 is greater than 0. 6 is positive, x square minus 3x plus 2 greater than 0. Already in quadratic inequations we solved, quadratic inequations we have studied. So, the factors of x square minus 3x plus 2 is x minus 1 into x minus 2 greater than 0. That means here actually x values you will be getting, if you equate to 0, 1 comma 2. That means here x less than 1 or x greater than 2, then it will be positive. So, here now required interval is minus infinity comma 1 union, R means union, 2 to infinity. So, that means fourth option is the right option. Fourth option is the right option. Second problem. Six goes that side, 0 by 6 is 0, or multiply with 1 by 6. The function f of x equals to 25 minus 4x square under root is increasing in first option minus 3 comma 0, second option is 0 comma 4, third option is minus 5 by 2 comma 0, fourth option is real number system R. Right. The function f of x equals to root of 25 minus 4x square is increasing in first option, second option, third option and fourth option. But in this problem actually we need to find out first step is step 1, find domain of f. It's very important in this question, domain of the function. Step 2, find f dash x. Step 3, here for increasing f dash x is greater than 0. Then within the domain, so we need to find out the solution here. So that means first of all let us find out the domain of this function. Domain of this function means 25 minus 4x square should be greater than or equal to 0. So this we can write like this: 4x square minus 25 is less than or equal to 0. If you multiply with minus sign, this product we can write 2x minus 5 into 2x plus 5 less than or equal to 0. Here x values will be minus 5 by 2 and 5 by 2. That means here domain x lies between minus 5 by 2 comma less than or equal to x, x less than or equal to 5 by 2. So here domain of f is equal to, domain is equal to, this will be useful for function chapter also, minus 5 by 2 comma 5 by 2. So in this interval only you need to check, this function is increasing or not. It's very clearly first option is not correct, second option is not correct, fourth option is correct, only third option will be the right option, but we will get it. I will show you, third option will be the right option here. So now first step has been completed. Now let us come to the second step. Second step means f of x equals to 25 minus 4x square root. Let us find out f dash x. So whose derivative is 1 by root x is 1 by 2 root of 25 minus 4x square, and 25 minus 4x square differentiation is minus 8x. This will be minus 4x by root of 25 minus x square, 25 minus 4x square. For increasing, we know f dash x is greater than 0. That means the minus 4x by root of 25 minus 4x square should be greater than 0. This cannot be 0. So minus 4x is greater than 0, multiply with minus 1 by 4, x will be less than 0. So now the domain, so let us take the domain here. What is the domain of the function here? Minus 5 by 2 and 5 by 2. 0 will be here, but according to the problem x less than 0, x less than 0 means now we need to shade here to here. That means in this interval it is increasing function. Therefore f is increasing in minus 5 by 2 comma 0. So that means third option is the right option. Fourth problem. The function x e power x is increasing in First option minus 3 comma 0, second one 0 comma 4, third x greater than minus 1, fourth option is 1 by e to infinity. That means in which interval in which interval the function x into e power x is increasing. Here you don't get any confusion here, x into e power x domain is all real numbers. So, that is why directly we can proceed for f dash x greater than 0 itself only. So, now the solution, here given f of x is equal to x into e power x, let us find out, differentiate both sides with respect to x, f dash x equal to UV method x into e power x differentiation e power x plus e power x into x differentiation 1. Now, you can take out e power x common, we have x plus 1. See, for increasing f dash x must be greater than 0, positive. So, e power x into x plus 1 is greater than 0. Here very interesting factor we have, see, e power x is always greater than 0 for every x belongs to R. X is any real number, e power x is always positive. E power x is positive means positive into positive, positive. Therefore, x plus 1 must be greater than 0. That implies x is greater than minus 1. So, third option is the right option. Third option is the right option. One minute. Right. So, now the fourth question, let us move to the fourth question now. Right. Right. So, let us go for the fourth problem now. The function log of log x increases in first option 1 to infinity, second option 0 to infinity, third option infinity, only infinity. So, third option is not the option for every real number R, Okay. So, now here the function log of log x increases in which interval? So, that means, for example, let us say the f of x equals to log of log x. So, let us differentiate it with respect to x, so that we get f dash x. F dash x equals to 1 by log x, but log x differentiation is 1 by x. this equals to 1 by x log x. So, for increasing f dash x must be greater than 0. That means 1 by x log x must be greater than 0. That implies, you remember one thing, 1 is positive, positive by positive. So, that means positive by positive you get positive, greater than 0. Obviously, this x log x also must be greater than 0. X log x must be greater than 0. So, now as for the here x value will be always, to define the logarithmic function, x must be greater than 0, or sometimes x lies between 0 to 1 also. So, two cases let us take it now. So, one case now you can take it, one case you can take it like this. Consider two cases. First, case 1. So, consider 0 less than x, x less than 1. Obviously, x is positive only, x is a fractional part. As x less than 1, here see, so here log x must be is less than log 1, 0, multiply with x, x log x is less than 0. That means f of x is decreasing, f of x is decreasing. That means in this interval f of x is decreasing. Consider case 2, consider case 2, x greater than 0. That implies here log x will be, sorry, x greater than 1 you take it now, x greater than 1 means log x is greater than 1, sorry, log 1, 0, multiply with x. So, x log x greater than 0, that means f of x is increasing, f of x is increasing. That means x must be greater than 1. See, x must be greater than 1 means we can write required interval is 1 to infinity. So, that is why the first option is the right option, first option is the right option. So, question number 5, the function sin h of sin x, sin h of sin x increases in first option 1 to infinity, second option 0 to infinity, third option infinity, fourth option 2n pi minus pi by 2, comma 2n pi plus pi by 2, n belongs to z plus. So, this is the question. So, weightage of this chapter is actually 3 to 4 marks, 3 to 4 marks, the maxima and minima. Right, let us see now. So, first actually here domain of this function is, for example, say domain of f is R, real number system, because for all real values sin x defines. So that is why directly we can differentiate now. Solution, let us say f of x equals to sin h of sin x, f dash x, function of function, sin h u derivative is cos h u, that means cos h of sin x into sin x differentiation is cos x. For increasing here f dash x is greater than 0. So cos h of sin x into cos x greater than 0. It is one logic is there, the cos h of sin x for all real values of domain of R, it will be always positive, because hyperbolic functions are the obtained from the exponential function only. Exponential function is, so I will tell you how can you say, how to find out the domain means here sin x. Sin x takes all the real values, but its range is -1, 1. That is why I evaluated R. So now it will be always positive. It is positive means positive into positive, positive. So that is obviously we get cos x is greater than 0. So cos x is greater than 0 means actually here cos x is positive, here coordinate system you need to take. This is first quadrant, second quadrant, third quadrant, fourth quadrant. All students take care now, stay at home, stay safe. So here cos is positive, here also cos is positive. So that means actually here see cos x is greater than 0 means, if you say cos x will be positive, cos x will be 0 in pi by 2 in first quadrant, in second fourth quadrant that will be image you need to take, minus pi by 2 comma pi by 2. In between minus pi by 2 comma pi by 2, this cos x will be positive. Understood now? So or if you draw the graph also, graph of cos x also, you see this is 0, this will be pi by 2, this will be minus pi by 2. See cos pi by 2 is 1, for example you say 1 here, you will be getting 1. Cos pi by 2 is 0, cos 0 is 1 here, cos minus pi by 2 0. You see in between minus pi by 2 to pi by 2 it will be upper curve, positive itself only, cos x is. So that means actually here x belongs to minus pi by 2 comma pi by 2, but general solution we need to write. General solution means at most general solution add to n pi. So that is why the fourth option is the right option. Sixth question. The function sin of tan hx, the function sin of tan hx increases in first option 0, second option R, third option 1, fourth option infinity. As for the options, fourth option, second option will be the right option. Okay, now here also tan hx is a hyperbolic function, its domain will be R only. So, we need to check now here. Let us say f of x equals to sine of tan hx. Let us find out f dash x derivative. Sine derivative is cos of tan hx. So, next tan hx derivative is secant h square x. So, for all x belongs to R, this will be greater than 0. That is why it is R. Second one. Seventh question. The function tan inverse sin x, tan inverse sin x increases in first option 2n pi minus pi by 2, comma 2n pi plus pi by 2. Second 2n pi plus pi by 2, comma 2n pi plus 3 pi by 2. Third option 2n pi plus pi by 4, 2n pi plus pi by 2. Fourth option 2n pi minus pi by 2, 2n pi plus 3 pi by 2. Here all n belongs to Z itself only. So, now let us see this question now. Function tan inverse sin x, the domain of sin x is R. So, that means the domain of this function is R only. So, whenever domain of the function is R, directly go for the differentiation. So, solution, otherwise you need to find out the domain. F of x equals to tan inverse of sin x. So, now f dash x, tan inverse derivative is 1 by 1 plus x square, 1 by 1 plus sin square x into derivative of sin x is cos x. So, this will be cos x by 1 plus sin square x. See, for increasing, the symbol stands for increasing. F dash x is greater than 0. That means cos x by 1 plus sin square x greater than 0. 1 plus sin square x is always positive. So, that means cos x must be greater than 0. Cos x must be greater than 0 means draw the graph now. So, if you draw the graph of the cos x, this is 0, this will be pi by 2, this will be minus pi by 2. Cos pi by 2 0, cos minus pi by 2 0, cos 0 1, maximum this is. So, you get one arch. Here minus pi by 2 to pi by 2, here x belongs to, you get minus pi by 2 to comma pi by 2. Because it is a trigonometric inequality general solution, add 2n pi. So, that means first option will be the correct option, first option. Otherwise, substitute n is equal to 0 in the options, check it, which is equal to minus pi by 2 comma pi by 2, that will be the answer. Okay. Eighth question. The function log x by x is increasing in first option 1 comma 2e, second option 0 comma e is the Napier's base approximately equal to 2.618, 0 comma pi by 2, fourth option is minus pi by 2 comma pi by 2. Okay. The function log x by x is increasing in which interval need to be evaluated. Solution, let us say f of x equals to log x by x. For this function we need to write the domain. See, the domain of the function is equal to x cannot take the negative values, x cannot take the 0. Here Ashwaradi, what's your question? So, domain of f is actually here, see, 0 to infinity, or we can say that x must be greater than 0. You remember this one. Now, let us find out f dash x. This is u by v method. First, v square x square, x into derivative of log x is 1 by x minus log x into x differentiation 1. So, we get now this equal to 1 minus log x upon x square. For increasing f dash x must be greater than 0. So, that means 1 minus log x upon x square greater than 0. Here see the condition, x does not equal to 0. That means x square never be 0, cross multiply. So, 1 minus log x is greater than 0. Right. So, now 1 minus log x greater than 0 means multiply with minus sign, you get log x minus 1 is less than 0. Log x is less than 1. That means log x is less than log e. So, you get x is less than e. But we need to check x must be greater than 0 domain. So, let us take a number line now. Number line, this is 0 and e lies in between one after. For example, say e, this is infinity. So, now x less than, actually what is the domain here, x greater than 0. So, you shade like this now, you shade like this, x must be greater than 0, but here x is less than e, x is less than e means you shade in reverse direction. So, what is the intersection part? 0 to e. So, therefore, now x belongs to 0 comma e. Here function is increasing. Second option is the right option. Second option is the right option. So, ninth question, ninth one. The function f of x equals to cot inverse x plus x increases in the interval is first option 1 to infinity, second option -1 to infinity, third option minus infinity comma infinity, fourth option 0 to infinity. Okay. The function f of x equal to cot inverse x plus x increases in the interval. Let us say f of x equals to, already f of x given, we need not consider, cot inverse x plus x, f dash x, derivative of cot inverse x is 1 by 1 plus x square plus x differentiation is 1. Here 1 by 1 plus x square is the LCM, minus 1 plus 1 plus x square is cancel, you get this is equal to x square by 1 plus x square. It is very clear, x square is always positive, 1 plus x square is also always positive, it will be positive for every x belongs to R. That means f dash x is greater than 0 here for all x belongs to real numbers. Therefore, x belongs to minus infinity comma infinity. Third option is the right option. Okay, next question. So, now let us move to the next question. Tenth one, the values of x, for which x cube minus 6x square minus 36x plus 7 increases R. Okay, first option R, second option null set pi, third option minus 2 comma 6, fourth option minus infinity comma 2 minus 2 union 6 to infinity. So, now the values of x for which x cube minus 6x square minus 36x plus 7 increases in which interval. That means it is a polynomial function whose domain is R. So, that is why here solution, let us say f of x equals to x cube minus 6x square minus 36x plus 7. Find f dash x. X cube differentiation is 3x square, this is minus 12x minus 36, 3 common, x square minus 4x minus 12. So, for increasing f dash x is greater than 0. That means x square minus 4x minus 12 must be greater than 0. What are the factors? X minus 6 into x plus 2 is greater than 0. Here if you equate to 0, you get x is equal to minus 2 and 6. This will be x less than minus 2 or x greater than 6. So, therefore, x less than minus 2 means minus infinity comma minus 2, or is union, this is 6 to infinity. So, fourth option is the right option. Fourth option is the right option. Okay, Narla Venkateshwarlu, Gopasri, Sanjharani, Bhargavi, you are new, Suma, Dishwank, Kishore, Harsha Sampath, Sai Kiran, Joseph, Dishwank, okay, I got it, Chintu, very good, very good. Next, 11th one, the function x to the power of x is decreasing in decreasing in. First option is 0 comma 1 by e, second option 0 comma 4, third option minus 4 comma 0, Fourth option is 1 by e comma 2e. See, the function x to the power of x is decreasing in which interval? Solution. First, let us suppose f of x equals to x to the power of x, f dash x. We have shortcut already, we have discussed. The derivative of x to the power of x is x to the power of x into 1 plus log x. Okay. So, that means for decreasing, so far we have solved increasing, for decreasing now. For decreasing, f dash x must be less than 0. That is why x to the power of x into 1 plus log x must be less than 0. But one more thing you remember, the x to the power of x is valid when x greater than 0 only. This condition, domain you need to remember. X to the power of x never be 0. So, 1 plus log x is less than 0. Log x is less than minus 1. This minus 1 equals to log e power minus 1, or minus 1 into log e is minus 1 only. So, this we can write log x is less than log of 1 by e. So, that means x less than 1 by e. Take a number line, now. See, x is must this 0 to infinity, x must be greater than 0, and 1 by e means in between somewhere. It's positive only, 1 by e here you take it. So, now x greater than 0 shade like this up to infinity. Next, x less than 1 by e, you take another color, you shade like this. Okay, intersection is here to here. That means therefore, here x belongs to 0 comma 1 by e. That means first option is the right option. Okay, now so 12th problem, f of x equals to cos inverse x is decreasing in first option minus 1 comma 0, second option 0 comma pi by 2, third option is minus 1 comma 1, fourth option are unreal numbers. So, f of x equals to cos inverse x decreasing in which interval, that we need to find out. Okay. So, now the solution, f of x equals to cos inverse x, differentiate it, f dash x equals to minus 1 by root of 1 minus x square. For decreasing f dash x is less than 0. that means the minus 1 by root of 1 minus x square must be less than 0. So, multiply with the minus sign, 1 by root of 1 minus x square is greater than 0. So, that means actually you remember this 1 minus x square must be positive, understood now. So, that is why 1 minus x square must be greater than 0, not equal to 0 also. That means x square minus 1 less than 0. This we can write x plus 1 into x minus 1 less than 0. Here x values will be minus 1 and 1. X lies between minus 1 comma 1. Minus 1 less than x, x less than 1. Therefore, x belongs to minus 1 comma 1. So, third option is the right option. Next question. Okay, 13th question. Yes, 13th question. In the interval minus 3 comma 3, the function f of x equals to x by 3 plus 3 by x. X does not equal to 0 is first option increasing, second option decreasing, third option neither increasing nor decreasing, decreasing, fourth partly increasing or partly decreasing. Okay. So, in this interval whether this function is increasing or decreasing we need to find out. In here one condition x does not equal to 0, that means the domain of this function is r minus 0, except 0 it accepts all the values. Okay. Now, f of x equals to x by 3 plus 3 by x. Let us find out f dash x. Derivative of x by 3 is 1 by 3, 3 by x differentiation is minus 3 by x square. This will be x square minus okay, keep like this one, no problem. Right. Let us do like this. For increasing f dash x is greater than 0, that means 1 by 3 minus 3 by x square greater than 0. For decreasing f dash x is less than 0. So, 1 by 3 minus 3 by x square is less than 0. Let us solve these two equations now. So, now you get like this 3x square. So, x square minus 9 greater than 0. here also x square minus 9 by 3x square less than 0. We get like this. Here x square minus 9 greater than 0. Here x square minus 9 less than 0. So, here x plus 3 into x minus 3 greater than 0. Here x plus 3 into x minus 3 less than 0. That means when x less than minus 3 or x greater than 3, it is increasing. When actually here minus 3 less than x, x less than 3, but x does not equal to 0. This condition is very important. So, that is why in minus 3 comma 3 it is decreasing function. So, that means second option is the right option. Second option is the right option, not partly increasing, partly decreasing. It is actually decreasing function only in this interval, but except 0, this condition is there. That means minus 3 to 0 union 0 to 3. This we can write like this, minus 3 to 0 union 0 to 3, because providing this condition. Okay, 14th question. If y equals to x cube minus ax square plus 12x plus 5 is increasing for all x belongs to R, for all real values of x, then A lies in which interval does A lie? Minus 12 comma 12, second option minus 11 comma 11, sorry, this is given question wrong. Okay, A lies between, only range asked. A lies between first option minus 12 to 12, second option is minus 11 comma 11, third option minus 6 comma 6, fourth option minus 10 comma 10. This is the question. So, actually here I have done for increasing and decreasing at a time I have done. Decreasing means x lies between minus 3 comma 3, that is only asked here, you see, minus 3 comma 3, decreasing. Okay. So, now y equals to x cube minus ax square plus 12x plus 5 is increasing for all x belongs to R. For every value of x it is always increasing, then a value we need to find out. So, that means for all x belongs to R, f dash x is greater than 0. So, now the solution, f dash x, let us find out. Y dash or f dash both are same, 3x square minus 6 ax plus 12. F of x is increasing for all x belongs to R is given. That means f dash x is greater than 0. That means 3x square minus 6ax plus 12 is greater than 0. In quadratic equations we have one theorem, x square coefficient a is greater than 0 and expression is also greater than 0. Expression is also greater than 0. It happens only when delta is less than 0. Delta means here comparing with a is 3, b is minus 6a, c is equal to 12. So, b square minus 4ac must be less than 0. So, let us do it now. 36a square, b square means 4 into 3 into c, c is 12, less than 0. So, this is 36, you can take 36 common, a square minus 4 less than 0. So, now a square minus 4 less than 0 means a minus 2 into a plus 2 less than 0. That means a lies between minus 2 and 2. Minus 2 and 2. I will check it the question once again, wait. Okay, I did wrong here. Yes, absolutely. Okay. Calculation mistake is there. Please wait. I will rectify because we have the calculation mistake. We did it. Right. Here derivative of x square is 2x, 2ax. B will be minus 2a. Okay. Let us do here only. What is b square? 4a square minus 4 into 3 into c is 12 less than 0. 4 common, a square minus 36 less than 0. That is why a square minus 36 less than 0. A plus 6 into a minus 6 less than 0. Therefore, a lies between minus 6 and 6. So, third option is the right option. Third option is the right option. Because actually I have taken actually here Now the 15th one. 15th one, if the function f of x equals to k sin x plus 2 cos x upon sin x plus cos x is increasing for all values of x, then first option k less than 1, second option k greater than 1, third option k less than 2, fourth option k greater than 2. This is the question. Okay. Now f of x equals to k sin x plus 2 cos x by sin x plus cos x is increasing for all values of x. Then we need to find out this condition now. First, say f of x equals to k sin x plus 2 cos x by sin x plus cos x, divide both numerator and denominator by tan x. See, we get like this: k tan x plus 2 divided by sin x by cos x is tan x plus cos x by cos x is 1. Now find f dash x. We have one shortcut, f dash x. So f dash x is equal to determinant of k 2 1 1 tan x coefficients. Here tan x coefficient k constant 2, k 2, tan x coefficient 1 1 1 upon we write 1 plus tan x whole square into derivative of tan x need to be written, that is secant square x. So we have this will be determinant of this matrix is k minus 2 into secant square x by 1 plus tan x whole square. See, for increasing f dash x is greater than 0. So it must be positive. That means k minus 2 into secant square x upon 1 plus tan square x, 1 plus tan x whole square, sorry, greater than 0. Secant square x is positive, this is also positive. So obviously we get k minus 2 will be greater than 0. So k is greater than 2. So that means fourth option is the right option. Fourth option is the right option. Okay. Now the 16th question. The 16th question, f of x equals to x by a plus a by x. A greater than 0 and x does not equal to 0 is decreasing in first option minus a less than or equal to x, x less than or equal to a. Second option 0 less than x, x less than a. Third option minus a less than x, x less than a. Fourth option is minus a comma 0 union 0 comma a. This is the question. Okay, now f of x equals to x by a plus a by x, a greater than 0, a is positive and x does not equal to 0, decreasing in which interval does this function is actually decreasing? We need to evaluate. Solution, here f of x equals to x by a plus a by x. Find f dash x. So x differentiation is 1, 1 by a by a x differentiation is minus a square by x square. Here a is positive already given here, a x square, a cancel, x square minus a square. See, for decreasing f dash x must be less than 0. So x square by minus a square by a x square less than 0. Here we know that a is positive, a x square is always greater than 0. Here negative by positive only you get negative, that means this must be less than 0. So x square minus a square less than 0. And next we get x plus a into x minus a less than 0. Okay. Okay, x plus a into x minus a is less than 0. That means x lies between minus a and a. That means x less than minus a or x greater than a. You take the number line now. This is minus infinity, this is positive infinity. Suppose take 0 here. Say this is minus a, this will be a. X less than minus a, let us shade it now. X less than minus a. So this part and x greater than a. Okay, next take another color. So one more thing actually here, sorry. wait 1 minute. So, therefore, actually according to this one you will get like this, x lies between minus a and a means minus a less than x, x less than a. So, now take the number line, this is minus infinity, this is plus infinity. Suppose 0, say this is a, this is minus a, x lies between a and minus a, that means you shade like this. But according to the problem here x does not equal to 0, x should not be included. X should not be included means we need to exclude 0. So, therefore, we get actually here x belongs to minus a to 0 union this interval, and this interval need to be considered 0 to a. That means fourth option is the right option. Fourth option is the right option. Okay, we shall continue in the next session. Thank you one and all. See you.